So the 11th question, why 6y is the particle moves along the curve 6y equal to x cube plus 2. Find the points on the curve at which y coordinate is changing 8 times as fast as x coordinate. So what it means is dy by dt, that is a y coordinate changing, equal to 8 times of dx by dt. So that's what the condition. So now we have 6y equal to x cube plus 2. Now differentiating left side and right side with t. 6 into dy by dt equal to 3x square chain rule dx by dt plus 2. Plus 2, when you differentiate, you get 0. So substitute this into this. That means 8 dx by dt equal to 3x square dx by dt. So this dx by dt gets cancelled. So which means 3x square equal to 8. X square equal to 8 by 3. X equal to square root of 8 by 3 plus or minus. Understood? This is what the
Yes, sir.
answer for x coordinate is this, and y coordinate obviously will be when you substitute that into this x cube. Okay, so y will be 1 by 6 of x cube plus 2. So x cube means 8 by 3, 8 by 3 to the power of 3 by 2 plus 2. So that is what is the answer for this.
Yes,
Okay,
sir.
so then next one, 12th question. The radius of air bubble is increasing with this. I'll copy this and then paste it onto a separate part here. One second. So this is the 12th question. So radius of an air bubble is increasing at the rate of 1 by 2 centimeter per second. C has given centimeter per second. You're able to hear me, right?
Yes, I can hear you.
Okay. So radius is changing. That means dr by dt. Yt, because it is per second, so equal to half centimeter per second. This is given. At what rate is the volume of the bubble? Volume of the bubble increasing when the radius is 1 centimeter. So as I said, formula for volume V of the bubble equals 4 by 3 pi r cube. So now it is increasing. It's at what rate it is increasing? So we just have to do dv by dt. dv by dt is to be found out. This is what the differentiation part, second one. Third one should be substitution. So dv by dt, this is the left side. Right side will be 4 by 3 into pi into 3r square chain rule, do dr by dt.
Yes, sir.
You could do this way also, or the other way I explained. First get dv by dr, that's equal to 4 by 3 into 3 pi r square So you will get 4 pi r square. This is dv by dr. So to get dv by dt, we did dv by dr multiplied by dr by dt. This also we can do. This straight away we can do this way, or we can do in the step way also. So dv by dt equals to 4 by 3. The 3 gets cancelled. That means 4 pi r square into dr by dt is half centimeter per second. So we need to substitute now dv by dt at r is equal to 1 centimeter. So r is equal to 1 centimeter. So that means I'm substituting 1 centimeter into this. 4 pi 1 centimeter square multiplied by half centimeter per second. So this 2 gets cancelled here. So you will get 2 pi centimeter cube. 2 pi centimeter cube per second. This is the answer. This is where volume will be changing. Understood?
Yes.
Okay, good. So 12th question done. Now 13th question. A balloon which always remains spherical has a variable diameter. Find the rate of change of its volume with respect to x. Okay. So we are taking this question. Variable diameter. So the diameter d is equal to 3 by 2, 2x plus 1. X is something. Okay. So the radius will be half of the diameter. That's equal to half 3 by 4 into 2x plus 1. This is the radius. So we need to find out volume with respect to x. So volume formula is 4 by 3 pi r cube. And what he requires is dv by dx. This is what is required. So first thing is, instead of r, substitute this. So you have 4 by 3 pi into 3 by 4 to 2x plus 1. This entire thing whole cube. This entire thing is whole cube. So take the numbers out. That means 3 cube. So let me first erase this dv by dx. We will do it later. We'll simplify this first. So 4 by 3 into pi into 3 cube by 4 cube to 2x plus 1 whole cube. So this will give me 1 3 gets cancelled. So it will become 2 square, 3 square. 1 3 will get cancelled with this. That becomes 4 square. So 9 by 16 pi to 2x plus 1 whole cube. This is v. Now if I differentiate this with x, I'll get 9 by 16 pi 3 into 2x plus 1 whole squared multiplied by chain root. So you'll have 2. So this 2 gets cancelled with this. So you will have 9 by 9 into 3, 27 by 8. 27 by 8 pi 2x plus 1 whole square. So find the rate of change of its volume with respect to x. This is what it is. Okay. So only thing we are not doing is I'm not checking the answers straight away. What just hold some time. I will check the answer also for this question. Yeah, the answer is 27 by 8 by 2x plus 1 whole square. Correct. And We did the 12th question, right? 12th question was 2 pi centimeter cube per second. 11th question is not correct. So we just have to look at the 11th question. Now, 11th question answer is not correct. This is the 11th question. This is the 12th question. So let's see 11th question one more time where we have done mistake. Y coordinate changing 8 times as fast as the x coordinate. That means dy by dt is 8 times 8 times dx by dt. Oh, yeah, there's a mistake. I'm correcting the mistake here. When we substitute this, right, I forgot the 6 here. So I need to put 8 dx by dt, and there is a 6 here. So I'm correcting that. So I'll get 6 times 8. So that means this entire thing is mistake. So we have got 48, 3x square equal to
So how did 8?
8, because this was 8 here, right?
Oh, okay. Yeah.
I didn't get the answer. That's why I was just wondering how come I got some root 3 and all. So 3x square equal to 48. X squared equal to 16. X equal to plus or minus 4. So when x equal to 4, then I substitute into this. Y will be 1 by 6. 4 cube is 64 plus 2, 66. So that's equal to 11. So one pair is 4 and 11. When x equal to minus 4, y is equal to, so minus 64 we will get. So minus 64, x cube is equal to minus 4. Minus 64 plus 2, that is minus 62. So you will have minus 1 by 6, right? So that's equal to minus 31 by 3. So that's the answer. Okay, these are the two coordinates. Now all
Yes,
are
sir.
done. 11, 12, 13 we have done. We have to look at the 14, 15 questions. 14, 15 is like economics, 15, 16 are economics related questions. 14 is again normal question. So we will take the 14th questions. 15th question. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. So this is volume and this is T. So dV by dt is given. That's equal to 12 centimeter cube per second. The falling sand forms a cone on the ground. That means you have a pipe, and from the pipe, the sand is pouring. So the sand has got a shape of cone. The height of the cone is always 1/6 of the radius base. So this is the height, and this is the radius. So height is always 1/6 of the base. Base is say R. How fast is the height of the sand cone increasing when the height is 4 centimeters? So how fast? That means time. So he wants us to find dH by dt. How fast the height of that is changing. So we need to find dH by dt. So since he has given h equal to 1 by 6r, this is the one we should be using. Of course, we need a formula for this. So first one is the formula for volume of a cone. or volume of the sand, equal to 1/3 pi r square h. And we eliminate r. Two variables are there. Since he is asking h, so we eliminate r. That means we substitute 1/3 pi r equal to 6h whole square and h. So we will get 36 by 3, this is 36 coming from here, pi h cube, h square here and h. So you'll have 12 pi h cube. This is the volume formula. Now differentiate both sides with respect to t. dv by dt left side equal to 12 into pi into 3h square multiplied by dh by dt, chain rule. That's why dh by dt. So we have to find this dh by dt. So take all other things to other side. So 12 3s are 36. So 1 by 36 pi h square into dv by dt equal to dh by dt. So dv by dt is given. That's a 12 centimeter per second. So we substitute this 12 cm cube per second equal to dh by dt and multiplied by 1 by 36 pi h square. Is 12, 3 is to go. So we have dh by dt given as 1 by 3 pi h square centimeter cube per second. He said h is given at h equal to 4 centimeters. So we need to substitute h equal to 4 here. So from there, now dh by dt, h equal to 4 centimeters equal to 1 by 3 pi 16 centimeter square multiplied by cm cube. Multiplied is not required, cm cube per second. So this cm square and this cube is gone. So you got 1 by 48 pi centimeter per second. So it's the height, and that's why you got centimeter, divided by dt, that's why you got seconds. So we are done with that question as well. 14th is done.
Yes, sir.
Next one is the 15th. Here only the wording is important, because economics question you need to understand the wording. The total cost of some producing, maybe say mobile phones or some material. So the cost, that's called a cost function. They'll have a cost function, demand function, supply function, like that in the economics. So the cost function, this is called a cost function. Since it is a function, that's why they said c of x. That's equal to 0.0007 x cube minus so many x square, like this. So x is what? X is units. Units meaning like how many phones, this many phones, x phones are produced. If x phones are produced, then the cost will be, you calculate this one, you will get that much is the cost. He says find the marginal cost when 17 units are produced. So the meaning of marginal cost, the word marginal, means differentiation of the cost function. That's all it is. Okay. So now we are doing that part of the question. We need to have the cost function to be copied. So let's go there and copy this 17 units. Where is it? Right here. So this is I'm I'm trying to see where it has put. Okay, so it's here. So question 15. So cost function is given as 0.007 x cubed minus 0.003 x squared plus 15x plus 4000. So then we need to have marginal cost is given as dc by dx. So dc by dx equal to 0.007 into 3x square minus 0.003 into 2x plus 15. This one is 0 and this is what it is. This is the marginal cost. He said find the marginal cost when 17 units are produced. That means x is equal to 17. So simply substitute that 0.007 3 into 17 squared minus 0.003 6 basically 2 is there into 17 plus 15. So if I calculate that, you need a calculator. This is 289 into 3. So let me get the calculator. Oh, I think the system is crashed. Okay, not crashed, it's gone. Okay. So we have this 3 into 17 square, 289 multiplied by 3 multiplied by point 0.007 for 6.069. So you will have 6.69 minus this one will be clear 17.006 multiplied by 17. It's equal to 0.102 plus 15. So 21.069. So you will have 20 21.069 minus 0.102. Oh, yeah, it's minus. Okay, so I think it's giving me minus yeah 20.967. One second, I'll close this off and then so that's the marginal cost question. So we have one more similar question. That's the 16th one. So 16th question is the total revenue in rupees received from the sale of X units. So I am reading this question here. So this is the one I'm reading. R of X is given, very much same. We have to differentiate R function. So we have to find dr by dx, then substitute x equal to 7. Okay. So I'm doing the 17th question on 16th question, not 17th. So differentiating this, I get dr by dx equal to 26x plus 26. So dr by dx at x equal to 7 equal to 26 into 7 plus 26. So 26 sevens, 140 plus 42, 182 plus 26. That's 182 plus 26. That's a 208. So this is the marginal revenue. It's called marginal revenue. And the previous one was a marginal cost function. So with that, then there is only one short question is there. Two short questions are there. One I copied, the other one I will tell that. So the first short question is, oh, I didn't copy the first also. Okay. So the first short question is rate of change of the area of a circle. So rate of change of area of a circle, that is given. So I'm just writing this short questions. So with respect to radius, so area of circle, we know it's pi r square. And dA by dr, so you will have 2 pi r. This one, when r is equal to 6 centimeter, when dA by dr, r is equal to 6. So that means you'll get 12 pi. So we have the answers as 10 pi and B is 12 pi, C is 8 pi, D is 11 pi. So the answer is 12 pi, because we already got that. Okay. Then 18th question. The total revenue in rupees received in sale of X units of a product is given by R of X is given. R of X equal to 3x square plus 3x square plus 36x plus 5. And what is the marginal revenue when X equal to 15? So X equal to 15, what's the marginal revenue? MR, we call marginal revenue. So you do dr x by dx. Let me put the options. Option A is 116. Option B is 96. Option C is 90. Option D is 126. So let's substitute this. We get 6x plus 36. You have to substitute 15. So 90 plus 36. So you get 126. So this is the answer. Understood, right? So far?
Yes, sir.
Okay. Now we are going to the next topic that's called increasing, decreasing functions. So that also I'll take a picture and then put that here. And let me go to next page. I'll have to explain a little bit. So the topic is increasing, decreasing functions. So what is the meaning or definition of the thing? So if we have a function f of x, you differentiated the function f dash x. If f dash x is greater than 0 in a particular interval, then we call it increasing function. If f dash x is less than 0, then we call it decreasing function in an interval a to b, some interval u to. So there is a third one which we'll learn in the next section. If f dash x equal to 0, then we call that either maximum or minimum. Either maximum value or minimum value. We also call this as a stationary function. So this we'll get in the next topic. A lot of questions will come on this. Okay. But for first, f dash x is greater than 0, increasing. Less than 0, decreasing. Then there is another terminology called strictly increasing and strictly decreasing. Strict means in general, I mean it is not just only for one part, it's continuously. So strictly increasing, for all the intervals it will be strictly increasing. Okay, simply that means for entire domain continues to increase. Then we call that as strictly increasing. Similarly, here for entire domain, it continues to decrease. Then we call strictly decreasing. So what does it mean? Okay, let's suppose, don't get confused on the graphs, but this is only for understanding. For example, I have drawn f of x like this. This is x. So here f dash x is nothing but the slope. This part, that means from x here to here, it's increasing. Here, not increasing, it's a flat. So here to here, that means from x values here, it's again increasing. So we can say that this is an increasing function here in this interval 0 to a, it's increasing, and again b onwards, it's increasing. But between a and b, it is flat. So if someone asks, between 0 and b, is it strictly increasing? The answer is no, because in between it is flat. So in this case, between 0 to b, it is just a increasing function, this one. So let's suppose we have another curve, f of x like this, and x like this, and you draw this curve. So if you differentiate here, you get positive slope. You differentiate here also increasing, here also increasing, here also increasing. So if I have the value b here, and let's suppose this is a1, this is a2, or rather a0, and this is, so for example, 1. So if I take 1 to b, is it strictly increasing? Yes, strictly increasing, because there is no flat part of it. It is continuously, for all points, it's increasing function. It's greater than 0. So this is one of the famous 1 mark questions and 2 mark questions, this particular topic. Okay? Whether they give
Okay,
the
sir.
previous exercise question or not, this exercise definite question will come. Okay? So we
Okay, sir.
are, yeah, going to the exercise 6.2. So exercise 6.2. So the first question is, show that the function given by f of x equal to, first question, 6.2. So f of x is given as 3x plus 17. Show that it is strictly increasing in R. Show that it is strictly increasing on R. R means this is the domain real numbers. Domain real numbers. That's why R. So how do we do? First one is f dash x. How much is f dash x? It is 3. So f dash x is greater than 0. Why? It is 3. For any value of x. For any value of x belonging to R. Let x be 0, 1, 2, 3, whatever, f dash x doesn't change because it's a constant function and it's greater than 0. Okay? Therefore, it is strictly increasing over R. Second question. Show that another function given by this is strictly increasing on f of x equal to e power 2x. F of x equal to e power 2x. So now, when we do f dash x, the differentiation of e power x is same, e power 2x, and 2x is there. That's why chain rule, you'll get 2. So 2 e to the power of 2x. So for this, we just have to draw a little bit of graph and say f of x, which is e power 2x, will be something like this. This is e power 2x graph. So it is continuously increasing. Or you can say that for no value of x, e of 2x is 0 and e of 2x is less than 0. Whatever value of x you give, it's always above the x-axis. So that implies that f dash x is greater than 0 for x belonging to R. Therefore, f dash x is strictly increasing over R. Any doubts?
No, sir.
No. Okay. So third question, show that the function given by f of x equal to sin x is strictly increasing in 0 to pi by 2, strictly decreasing in pi by 2 to pi. Two parts are there for third question. Just I will, I think I can, is it okay? I read that from textbook. I'm not copying the question onto the screen. Okay. It is there in the textbook. I'm reading from
Yes, sir.
textbook. Okay. So we have to show that f of x equal to sin x is strictly increasing for the interval 0 to pi by 2 and b strictly decreasing for the interval pi by 2 to pi. So as usual, we have to differentiate f of x equal to sin x. So f dash x, f of x equal to sin x, f dash x equal to cos x. So now, if you remember the cos curve, 0, pi by 2, pi, 3 pi by 2, 2 pi. So we know that at pi by 2 it is 0. Like that the graph will be. This is 1, this is minus 1. So now we have differentiated f dash x. So we need to check between 0 to pi by 2. So we are seeing f dash 0 equal to cos 0. That's equal to 1. Then we look at f dash pi by 2. That is cos pi by 2 equal to 0. Correct?
Yes, sir.
So now we have to see, he said this is the kind of bracket he has used. That means pi by 2 not included. Okay. So that means any other value, you should try for f dash pi by 2 equal to 0, not to be in the range, because we have a curve bracket. If it is a square bracket, then we have to see. So if you do not consider pi by 2, then any other value for all values of x between 0 and pi by 2. When we say 0 and pi by 2 between, they are not included. F dash x is definitely greater than 0. See, you are seeing this to be greater than, this is f of x. Sorry, I have written f dash x. This is f dash x. So this is greater than 0, this part. That's why it is strictly increasing. So that implies function is strictly increasing in 0 to pi by 2. Now the second case, the B part. B part. So cos x, f dash x, cos x, and we have to worry about pi by 2. So f dash pi by 2 equal to 0, f dash pi, that's equal to cos pi. This is minus 1. So that implies that f dash x is less than 0 for all values between pi by 2 and pi, values of x between pi and pi by 2 and pi. So therefore, f dash x is strictly decreasing in pi by 2 to pi. So that's the third question. Sorry, second question, third question B. There is one more part, C. C part is we have to show that it is neither increasing nor decreasing if you take the intervals 0 to pi. So what he is trying to say, between 0 to pi by 2, we got this as a strictly increasing. Between pi by 2 to pi, we got strictly decreasing. So both increase and decrease happening if you take both intervals together. And therefore, since f dash x, or rather f of x, is both SI and DI, SI and SD. Therefore, it is neither increasing nor decreasing over total interval 0 to pi. So this is the English we have to write there. Then
Yes, sir.
question number 4. Question number 4 is we have to find the intervals for which a function is increasing or decreasing. Find intervals in which f of x equal to 2x square minus 3x. F of x equal to 2x squared minus 3x. First part is where it is strictly increasing. B, where it is strictly decreasing. We need to find intervals. So first thing is you need to say f dash x equal to 4x minus 3. So 4x minus 3. Now we have to check for what values of x this is greater than 0. So case 1. 4x minus 3 must be greater than 0 for f of x to be SI. So now x equal to greater than 3 by 4. So greater than 3 by 4. That means we will say 3 by 4 to infinity. So 3 by 4 to infinity. So you look at this, these brackets are important. We have to put as a curve bracket. It is strictly increasing. Then come to B. So you look for same 4x minus 3 less than 0. X is less than 3 by 4. So we'll have to say minus infinity up to 3 by 4. So it is strictly decreasing. These are the values of x. A similar question is the fifth one, but many times the fifth one was asked many times. So f of x equal to, because it's a cubic function, 2x cubed minus 3x squared minus 36x plus 7. So is strictly increasing, B strictly decreasing. He's asking find the interval. This is the question. Find interval. So we differentiate. We get 6x squared minus 6x minus 36. So it's a quadratic. So let's simplify this. Take out x6 common. You got x squared minus x minus 6. Then you have 6. Factorize this. So you will have x minus 6 into x plus 1. Is that correct? No. X minus 3. X minus 3 to x plus 2. This is how factorized. So since you got f dash x equal to this, definitely the points are 3 and 2. That means we need to consider number line. X equal to minus 2 and x equal to 3. So definitely at this place and this place, f dash x is 0. So we need to see what happens from this interval to this interval. What happened this interval to this interval. what happens this into this? Four intervals are there. First interval, second interval, third interval, fourth interval. This is less than -2. This is between -2 and 0. This is between 0 and 3. This is greater than 3. Okay. So let us substitute anything less than. This is, let's call this as a region 1. This is region 2, region 3, region 4. So for region 1, which is less than -2. So give some -3. Let's put -3 value here. So when you put -3, 6 into, you have a negative value here. This is also negative value. So totally you will get positive. Negative into negative, you get positive. So it's greater. So region 1 is strictly increasing. So let's consider this next part, region 2. So region 2 is, let's give -1 value. Then this is minus, this is plus. So you'll get as a negative. So this means R2 is strictly decreasing. This is strictly increasing. R3, 0 to 3, give value 1, for example. So this is negative, this is positive. 0 to 1, I am giving, this is negative. So everything is negative, strictly decreasing. The last one, anything greater than 3, definitely greater than 3 will be entire thing is positive. So strictly increasing. So he is asked which intervals, this and this, R1 and R3. This is R1 and R3, R1 and R4. So we have to write clearly, this is R1, this is R4. So for x less than -2 and x greater than 3, strictly increasing. That's the first one. The second part, in all other intervals, that means between -2 and +3, strictly decreasing. So this is the for A and this is for B. I hope you understood.
Yes, sir.
So I will quickly recap this rather than rushing. Okay. Recap only these 4 questions we have done on strictly increasing and strictly decreasing part. Okay. The increasing decreasing functions. So that means this page only we are reviewing it. We have 5 minutes. That's why better to review it. So increasing, decreasing functions, and we want to talk about f of x, f dash x. If f dash x is greater than 0, it is just increasing function over the interval a and b, a to b. If it is less than 0, we call it as a decreasing function. If it is equal to 0, that is called a stationary point, which will come later. So in addition to increasing and decreasing, there is a strictly increasing, strictly decreasing. That means for the entire domain, it is continuously increasing. Then we call it as a strictly increasing. So this particular case, what we are seeing here. So you have an increasing for this interval, and for this interval flat, and for this interval again increasing. So this function is just increasing function. It is not strictly increasing function between 0 to b. Take this function. Everywhere it keeps on, the slope is high. It's positive. So between here to here, it's increasing. Between here to here, it's increasing. Between here to here, it's increasing. So it's considered from 1 to b. It is continuously increasing. Therefore, it is a strictly increasing function. A similar example for strictly decreasing. So we have started with exercise 6.2, first question. Show that this is a strictly increasing on entire real values for x. F of x equal to x plus 7. We differentiated, we got f dash x equal to 3. So this 3 is greater than 0. So f dash x is greater than 0 for any value of x between the domain x belongs to R. Therefore, it is strictly increasing for that entire region R. Now the second question. So we have e power 2x function, and we have put the graph for e power 2x. It's always greater than 0, and therefore Si strictly increasing over the all values of x. Third one, show that f of x equal to sin x is strictly increasing between 0 to pi by 2 and strictly decreasing between pi by 2 to pi. So if you actually draw the function, the curve for sin x curve is this way. This is sin x. So between 0 to pi by 2 is this. This is between 0 to pi by 2. So slope is increasing. This is pi by 2 to pi. Slope is decreasing. So what we have done, we have differentiated and we got f dash x, which is cos x. So in the x, we have given the limits, that means the whatever is the domain, 0 and pi by 2. We give 0, cos 0 equal to 1, pi by 2, we got 0. So between that 1 and 0, that means you don't include these values pi by 2 and 0. So for all other values, it is positive only. Therefore, it's strictly increasing. Similarly, we have done for pi by 2 to pi, you get minus 1 and 0. That's why we say it's strictly decreasing. Between the intervals, if you take total 0 to pi, if it is increasing as well as decreasing, then we call that as neither increasing nor decreasing between that intervals. So fourth question, we need to find the intervals, fourth question and fifth question. So the function is given and find the intervals in which it is strictly increasing, find the intervals in which it is strictly decreasing. So differentiated, we got 4x minus 3. Then we use inequality. We put greater than 0. That means for any value greater than 3 by 4, this is positive. So we indicate this way. The intervals are to be indicated this way with a curved bracket 3 by 4 to infinity. You can also write x is greater than 3 by 4. We can fully write x is greater than 3 by 4. That also we can do. So for next, we did the less than 3 by 4. So for this also, you can say x is less than 3 by 4 is the answer. Fifth question, important, is given many times. So we have taken 2x cubed minus 3x squared plus minus 36x plus 7. Find intervals for which it is strictly increasing, in which it is strictly decreasing. So we differentiated, we got the quadratic. This is important because we consider factorized this quadratic, got x minus 3 into x plus 2. This is same as what we did in the 10th ICSE. So we have considered the number line for these values minus 2, 0, and 3. 0 comes between minus 2 and 3. That's why we mark that number line. So we consider 1, 2, 3, 4 regions. For each region, we substituted one value in that region for x. So we substituted here between minus 2, less than minus 2, we substituted, for example, minus 3. Then the first one is negative, the second one is negative. Therefore, the total becomes positive. That's why in the region 1, it is positive. In the region 2, it is negative. Region 3, it is negative. So R2 and R3 is strictly decreasing. R1 and R4, it is strictly increasing. That's how we answered this fifth question. Okay, so then we have to continue from sixth onwards, right? Any question?
Yes,
Any
sir.
doubt?
No
Understood?
question, sir.
So I will upload this one entire thing, recorded one on the YouTube. Okay, I will send you the link. If I don't send the link also, it will be there only. Okay, I will send the link.
Yes,
All
sir.
right. Okay. So we are done, right?
Yes, sir.
Right. On Friday we'll
Thank you,
continue.
sir.
Right.
Okay,
Bye.
sir. Thank you, sir.
Bye. Yeah.